It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear. So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 206 of Science on Top. Today is Sunday, the 8th of November, 2015. I'm Ed Brown and I'm joined by Penny Dumsday.
Hello.
And Lucas Randall.
Hello.
Penny, some really strange news this week came from the US Centres for Disease Control and the UK's Natural History Museum, who determined that a man died from cancer that he contracted from a tapeworm. This is cancer that's crossed species from a parasite to the host.
Yeah, which is not something I'd ever really heard of before, especially not the only contagious cancer I can think of, and maybe someone can correct me if there's more, but is the Tasmanian devil facial tumours.
Oh, of course.
It's the first thing that sprung to mind when you said this. I was about to say, and don't forget the Tasmanian devil.
Yeah, I can't think of any other ones. Like, as far as I know, cancer tends to not be contagious. So this is a whole new nightmare. Although there's some things about the case that make me think most people probably don't need to worry too much.
It's a unique case.
It's a reasonably unique case. So it's a man in Colombia and he had tumours in his lungs that looked quite unusual. The cells in them were really tiny compared to human cells and quite different. And it turns out that these masses in his lungs were cancer cells that came from a tapeworm living inside him.
How do you even know that they came from the tapeworm? Can you genetically analyse them or something?
Yeah, I think they looked at DNA from the cells.
Wow.
So they sort of knew that they might not be human. Well, the hint was the size, because they were quite small. They acted like cancer cells, but they came from this tapeworm called H. nana. And they weren't expecting that because they didn't look like tapeworm cells either. But, you know, DNA is DNA. There you go.
Yeah, fair enough.
But the thing that makes this a bit unique, and sadly for the man who had it, but luckily for most people, is that the man had untreated HIV. So he had HIV. He wasn't receiving treatment, and that meant that his immune system wasn't attacking the tapeworm. So the tapeworm could keep growing.
Right.
Its cells started mutating and becoming cancerous, which then transferred to him. Because I also didn't even know that tapeworms could get cancer.
Well, me neither, but then I sort of think, well, why wouldn't they?
Yeah. They're only a couple of layers of cells thick, but I guess also, I mean, I don't think, Anyway, there you go.
Well, it's obviously rare because we don't hear of tapeworm cancer for a start, let alone spreading into humans. But, immunocompromised system makes sense that's why the tapeworm would still be there.
Still be there. It wouldn't be attacked.
Yeah.
But so that's
scary, but not too scary, I guess.
Not like we can still sleep at night. But I do feel very sorry for the patient because only 3 days after that they figured out what was going on, he passed away.
Wow.
So there's not really enough time to come to grips with what's happened, let alone discover a treatment and potential cure.
Makes you wonder if they knew he had tapeworms to begin with or something. But it sounds like he's obviously not getting a lot of medical care.
I'm guessing I'm just supposing there's probably a bit of poverty and so on affecting.
Yeah, very sad. But there's more reasons to fear the tapeworm, isn't there?
Yes, thank you for digging all these out.
Well, it's a coincidence that these happen in the same week. A Californian man has had a tapeworm removed from his brain in what was really urgent, life-saving surgery. I think they discovered it about, was it half an hour before he would have died or something?
Yeah, apparently he'd been having headaches for some time, but didn't think much of it. But then one day he became disoriented, he started vomiting. His mum took him to the hospital, and after a whole lot of testing they found a tapeworm larva lodged in his brain, and apparently when they took it out, it was still wriggling. Now I just paused then to have chills. Ugh.
And so it was embedded in his brain in a way that it was blocking the flow of water to his brain. And if that blockage had continued for another half hour, it would have killed him in the end. So,
yeah,
lucky that
I had no idea.
Yeah,
he must have eaten something, but
yeah, it's usually pork, uncooked meat, and it's passed on by bad hygiene from whoever prepares the food. But once it gets in the body, sometimes they can just make their way to the brain, which is a really weird thing. And I can't think of any sort of evolutionary reason for that. It's not like toxoplasmosis, which goes to the brain of a cat and steers it towards brain of a rat and steers it towards cats or something.
Well, I mean, because tapeworms actually need to be excreted through feces to reproduce. I'm guessing it's just they just go somewhere, and as long as some of them end up in the gut, good for them.
Didn't know his ass from his brain, as it were.
But yeah, anyway, at least this poor guy, he's going to have some therapy, or he's having therapy to recover his memory and exercises and so on, mental exercises. But oh God! So thanks, Ed, for finding these stories.
I think it's always good to start the show off on a
cheerful note.
Yeah. Well, he lived. That's cheerful. But yeah, it's kind of worrying that these things happen. But although I think that it's a very rare thing. The CD says about 1,000 people per year are hospitalized for neurocysticercosis and removal of the larvae. Yeah, I'm just going to steer clear of pork for a while, but that's just me. Lucas, we're still learning a lot from the Rosetta probe orbiting the comet, say it with me, 67P Churyumov Gerasimenko.
There you go.
And
well
this week, the spacecraft has detected significant levels of molecular oxygen, which is really unexpected.
It is, and it's not just unexpected, but it's kind of one of those moments of, oh, crap. Because there's, one of the things that we've been looking for quite some time, and we'll continue to look for, and probably until we find it or just, die trying, is evidence of life on another planet. We've got evidence of life on one planet, this one. So that's, 100% confirmed. So, lucky. But
well done, science.
But, we're looking for life elsewhere in the cosmos just to find out whether we're alone. And one of the very high on the list things that we look for when we're trying to find a planet that we can remotely detect life is the existence of molecular oxygen, because it's something that tends to be, we thought, fairly much a key indicator of life. Obviously, on Earth, it's predominantly created by the processes of plants, growing.
Synthesis.
Yeah, exactly. So, Earth, received a huge amount of oxygen, a long, long time ago due to, the very first algae sort of organisms pumping out huge amounts of oxygen, which then paved the way for, the rise of the animals much, much later on. So, this is a process that tends to, in our experience, require plant life, or at least, very, plant-like life. And the reason for that is because oxygen is a volatile. It doesn't tend to survive in an atmosphere. It will be lost if it's not replenished. It gets lost out to space. So, it's
so how do we find it on a comet then?
Well, it's a good question. We send a probe. Sometimes the probe has a lander that gets a little bit lost and doesn't come back, which was a bit of a shame. But in this case, we sent a probe. We sent the Rosetta probe, and it's been monitoring for all sorts of stuff. One of the tools, one of the instruments on the Rosetta probe is a mass spectrometer, so it's able to measure, it's able to deduct from the light or the colours of light that come from basically through the gases that it's looking at. It can look at those colours and can figure out what chemicals are in the gases. So that's spectrophotometry. We use the same thing for looking at stars and figuring out what what makes up stars, because we can deduct that from the colours of light and the light absorption bars.
What I actually mean is how do we find it on a comet that's travelling through space? And as you say, oxygen being a volatile thing, it's likely to break down and get lost or whatever in space. So is this just that it was sort of buried under layers of more comet, which has been sort of evaporating and...
Well, that's the real question at the moment. What was interesting to me is the team actually found this quite a long time ago. It was over a year ago that they first discovered this unexpected molecular oxygen, and what they decided to do at the time was to sit on this and to study it more, just to see whether this was something that was just related to the comet's outgassing as it did its little trip around the sun, because they know that comets, when they go around the sun, and this one's been around the sun many, many times, they would tend to lose anywhere between 1 and 10 meters of their surface every time they loop around the sun. So it depends on their composition and how close they get to the sun and all these sorts of things. But basically, because comets, have got a lot of ice in them, because of where they come from, they tend to sort of lose a lot of their mass when they flick around the sun. So in this case, they thought, well, maybe this is just an outgassing event. Maybe there was some oxygen trapped there somehow or whatever. Let's just have a look and see what happens. But what they discovered was that the oxygen that was being released was fairly constant, and it was also constant regardless of which side they were measuring, because they had a theory that if it was just related to the outgassing, and if it was a very short-term event, you would tend to see a difference in the amount of oxygen to water ratio depending on which side was facing the sun. But that's not what they saw. They actually saw that it was more or less the same. They also found that it was more or less the same right across the areas of the comet that they were measuring, indicating that it's actually quite constant within the comet. Now, if there's this molecular oxygen being replenished in the comet through some kind of process, that's some sort of chemical process that's occurring, and there are some possibilities that would cause this, then they would expect to see changes in the amount of oxygen that's being given off, but that's not the case. They're seeing it's fairly constant. So that would tend to indicate that this is actually embedded within the comet and embedded right throughout the comet, which then takes us back
at the moment of formation, then, when the comet first formed. Wow.
Yeah. So the other thing I didn't actually realise about this comet was that it's two comets. So we all know, that kind of weird rubber ducky, looking thing that this comet is. Yeah. It's actually two comets that have joined together at some point in time. So they're probably formed out of the same nascent material in a very similar region of the solar system, because if comets smack into each other, usually they would, kind of obliterate each other if they're a roughly similar mass, which these are, fairly similar. So the fact that they're quite distinct blobs that are attached to each other would tend to indicate that it was a fairly slow merger, so they kind of just slowly drifted together. And given that they've, both got this same sort of characteristic of amount of oxygen in there, it tends to indicate that oxygen may be, I should say, molecular oxygen may be more prevalent in the cosmos than we thought. We certainly don't see it much. We've only detected it twice in the interstellar sort of medium before. So it's been earmarked as something very, very useful to look for to find life, because we just don't see it much out there.
So it could be that oxygen is more common throughout the universe, or just that our solar system may be formed in a patch that was higher in oxygen.
Absolutely, maybe. And that's something that the team have raised as a possibility as well, that maybe. And it's amazing how often you hear, because I remember right through the the 90s and my interest of reading about this sort of stuff, there's this constant sort of proposal that we shouldn't think that we're special in any way, that there's anything special about where the Earth is or the time that we're in or whatever. But it seems the more we learn, there's more and more things that are in fact very special about this place, this time, and the series of events that led to us being here. Were incredibly unlikely, and maybe this is another case of that where, the protoplanetary materials that were there prior to the formation of the solar system may have come from the destruction of a star or stars that were extremely rich in the right materials for to lead to this sort of molecular oxygen being very abundant.
It's almost as if it was planned that way. No, anyway.
Yeah. So anyway, as usual, this sort of stuff raises a whole lot of more questions, which is cool. I mean, that's why science is exciting, because you find things that you don't understand and can't easily understand. So now it'll be up to more observations and more scientists to pitch in and suggest things that could cause this. But at the moment, it's a bit of an unanswered question, which is very cool.
Awesome. And I love that Rosetta is still giving it, well, as you say, this was a year-old finding, but I like that we're still learning stuff about this comet.
Yeah.
It's very cool. All right, Penny. A study of how jellyfish move has surprised researchers. Instead of pushing against the water, the jellyfish kind of pull themselves through it. They really do suck, don't they?
They really suck. No, I think I've always found jellyfish quite beautiful, and I guess I've never really thought much about how they swim. Most things, when they swim, seem to put pressure, make high pressure against the water or the air. So if you think about swimming, like in the breaststroke, for example, you're pushing against that water to propel yourself through, to make yourself go forwards. But apparently what jellyfish do is a bit different. So this study was done by getting jellyfish and, incidentally, lampreys, which are a very sort of primitive kind of jawless fish, and they swam through tunnels of water which were full of tiny, tiny glass beads, which means that the motion of the liquid was quite visible, and they recorded this to look at it so that they could get a sense of how the water was flowing around the jellyfish and around the lampreys. And just a brief note is that jellyfish, of course, aren't actually fish. Yep. They're a much more simpler kind of organism. So it's interesting that a fish, the lamprey, as well as jellies, do this same way. What happens is, instead of pushing against the water, an area of low pressure is created above the dome of the jellyfish, which kind of sucks it forward. And it seems to be created by the rotation of the body, and which creates, and this is a bit of physics that I'm not 100% sure about, so I'm just going to read it from the article, is that they create a swirling vortex with a low-pressure area at the centre. So I'm guessing kind of like an underwater whirlwind that will suck the jelly into it.
Okay. So that's kind of cool, because I
think that's cool.
When you see a jellyfish moving, it does kind of look like that umbrella is kind of pushing the water out behind it.
Sucking and blowing sort of.
Yeah, but obviously that's deceptive, and that's not what's actually happened.
Yeah.
I would love to see this experiment. I would love to see these glass beads in the flume like that. That would be really cool, I think.
I would like to see that too. I think it would be beautiful, but so interesting.
Yeah.
And it is really interesting because, I mean, I know we often say this, but, I mean, it's such a different way of conceptualizing movement. Like, you wonder what kind of boats or submarines or cars, aeroplanes. Yeah.
Yeah, I can't see cars spinning around that much, but yeah.
No, but, I'm not an engineer, so who knows what they can see.
That's true. But so, and the lampreys, are they spinning around, or how did they find anything by watching them?
I'm not sure what the lampreys did.
Because they have a sideways body mode.
Yeah, they have a sideways one, which seems to. So I think they have high pressure as well as low pressure.
Okay.
But I didn't quite understand the lamprey angle. but I did think it was interesting. Because they're quite
Hydrodynamics is
interesting
confusing.
fish. If you don't know what a lamprey looks like, do Google it. It's worth it.
Aren't they? They're toothed fish, aren't they? They're vicious man-eating things.
They don't have jaws, so they kind of like suction onto stuff, but they do have like very scary mouths full of teeth.
Cool.
I hear someone goose.
That was me. Yeah. Oh God, they've got teeth. Absolutely.
Yeah.
They look a lot like when the Millennium Falcon is in the crater.
I'm with you. Yep.
Yeah.
Star Wars might be a bit on my brain at the moment.
Damn right. I'm a little surprised that this hasn't come up before. You know, I mean, like, surely, there's jellyfish in tanks all over the world, and they, as Penny said, they're beautiful things to look at. Surely someone's noticed this before. I mean, and why did it take glass balls? I was imagining these lampreys and the jellies being in this kind of this fluid tunnel, going hit by this giant. But why did it take balls? Why not just like die or something? Like, you know, I'm thinking of wind tunnel experiments or whatever. Surely that would have shown these vortices forming. But it kind of, I mean, you know, despite it not being the obvious thing you would think when you look at them, you think of fluid dynamics and the way that things need to move through liquids, and you know it's very, very different to the way things move on land, and it's not intuitive in the same way. And there are, like, there's things about, even, you know, you think of breaststroke, for example, where you are pushing against the water, but I imagine there's also the negative force that's creating of your arms moving away from the liquid in front of you as well, which would help to pull you forward as well.
Yep, correct.
So it's kind of not as intuitive as you'd think. But yeah, I'm just a little surprised that this wasn't known already.
But I'm guessing you can imagine someone going, they want to study how jellyfish move. What's the point of that?
What use is that?
Why aren't they curing cancer?
Yeah, because as everyone knows, you know, as soon as you stop to look at how jellyfish swim, all of the efforts around the world to cure cancer stop. Everyone just pauses while you figure that out.
Suddenly tapeworms start spreading cancer. Oh, wait. But I think also, like I said, they do deceptively look like they're pushing the water away, and maybe just people have always assumed that that's what's happening.
Well, I never thought about it.
Yeah.
It was almost a no-brainer.
But yeah, I mean, you don't stare at jellies all day long. I'm sure there's people who stare at jellies all day long. At some point, would have noticed something and gone, huh?
But also,
well, obviously they have. It just took longer than, you know.
But I wonder about actually even doing this experiment. Like, you've got to have enough current that the little beads are going to be floating past the jellyfish. But you've also got to get the jellyfish to be moving in the opposite direction to that current, which isn't necessarily going to happen. Like, how do you bait a jellyfish?
They're not exactly smart.
Yeah. So I think it's a really interesting experiment, and I'd love to see it in action and to get more information on that. But don't have that information at the moment. But it's very cool.
I was just thinking of, you know, weird stuff about fluid dynamics, and there's this video that did the rounds a little while ago, maybe a year or so ago, of this guy, a father, showing his kids what happens in a car with a helium balloon.
Yes.
Do you know the one I'm talking about?
I do. That was I forget his name. Describe it while I think and remember who it is.
So basically he did two experiments with his kids, and it was the idea of this was to show that a container of air is in fact a container of liquid, because fluids are fluids regardless of gases or liquids. So what he showed was he had this helium balloon attached via a string to the floor of the car. It was like a van, and as he drove forward, the helium balloon actually moved forward in the car, not backwards. You kind of would intuitively think it would go backwards because of the force of acceleration pushing it to the rear. But what was actually happening was, as the car moved forward, the force of acceleration pushed more of the air towards the back of the car, which in fact pushed the balloon forward because it's lighter than air. Then they did another experiment with the balloon was it a balloon? I think it was a balloon hanging with some heavier gas, I'm not sure what it was, in the balloon from the ceiling of the car, and it acted in the opposite way. So, yeah, it's just kind of cool little things about fluid dynamics.
Yeah, it
you can
was
do with kids.
Smarter Every Day.
Yeah, that was it. Yeah.
I think it is, yeah. Great channel, by the way. Also does a lot of work with Veritasium. Yeah, so check that out. We'll have a link to that little video.
Sorry,
anyway.
I just made more work for you. You're going to put more links in there?
Links are easy to do. They're copy and
Okay.
paste. But, yeah, no, very cool. And hydrodynamics, fluid dynamics is often a counterintuitive thing. I was a swimming coach long ago in a past life. And one of the things that we had to learn was that longer boats go faster. So you think of it, if you take two boats that are exactly the same shape and everything, the longer one is going to be faster.
Really?
Just the way the currents work around it and everything. So we're always teaching our swimmers to extend and stretch out as far as they can in front of them.
Which then helped them accept their 8 hours on the stretching rack. After.
That's true. People thought it was just torture, but it was actually a sensible training thing. No, so all sorts of things like that you just think wouldn't work or wouldn't be the case, but they are. So all the more reason to study things like jellyfish, because maybe we'll find more ways to help our Olympic athletes and, as you say, maybe design better submarines and boats and things like that. So very cool stuff.
Indeed.
And I think that's our show. As usual, all the links are on the web at scienceontop.com/206. Leave us a comment there, or you can send us an email at feedback@scienceontop.com, and Twitter, Facebook, Google+, all of those. Penny, Lucas, thank you both so much for joining me today.
Always a pleasure.
And a big thanks to everyone for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
Told me it was like uncooked pork sometimes. If I went swimming in the river, or if I've been to like a third world country, and I was like, well, I haven't done any of that recently. And they're like, hey, you have this parasite in your head. We're going to have to operate, and we have to do it soon. Otherwise, you could probably die. Yeah, the doctor pulled it out, and he said it was still wiggling. And I'm like, oh, that doesn't sound too good.